Okay, so moving along here now, because of the zero product property, remember the zero product property says if the product is equal to zero, then we know that each factor can be equal to zero. And when we talk about products and factors, reminder, we're talking about multiplication. So we want to learn how to change things into factored form, meaning multiplication. Here's a warm-up question. I want you to pause the video, take a second, and see if you can answer this warm-up question. Okay, welcome back. Well, this is based on the idea that we know the vertex, the x-coordinate of the vertex, or the axis of symmetry, they're the same thing, right? I don't know why I did a lowercase y there. The axis of symmetry must be in between the zeros and the x-intercepts, and the x-intercepts are -3, 0 and -1, 0. So I know that the axis of symmetry must be between -3 and -1. So let's see, the function f is defined by that, right? Yeah, that's -3, -1, which defined as contains the x-coordinate of the vertex. Well, I know that the vertex is right in between -3 and -1. So I actually know that the axis of symmetry is -2. So the answer is -2. And what interval is -2 on? That is on this interval here, B. All right. Warm-up number 2, find the equation of the parabola that has an x-intercept of 2 is 6 and a y-intercept of -24. So if we have x-intercepts, I'm going to use factored form. All right. That's our factored form. I don't quite know what a is yet, but I know my x-intercepts, they go here, x minus 2 times x minus 6. And now if they tell me the y-intercept is -24, that means I have another point besides the x-intercepts on the graph, and that's going to be 0, -24. Why do I know that? Because y-intercept always has an x of 0. I'm going to use that other point temporarily. I'm going to temporarily plug it in to find my a. So -24 goes in for y. Here, let me rewrite the equation over here. Y equals a times x minus 2 times x minus 6. I'm going to plug in -24, a, plug in 0 for x. So -24 equals a times -2 times -6. So -24 equals a times -2 times -6 is 12. So I can write that as -24 equals 12a. I divide both sides by 12 and I get a equals -2. Now I can write my final equation as y equals -2, x minus 2 times x minus 6. All right, so there's my equation outline. If you're given the two x-intercepts, that's how you can go about it. Keep in mind, you do need that third point, right? We need 3 points for a parabola, and I plug in that other third point to solve for a. So now I know which way it opens and all that stuff. All right, now we're going to look at how do we factor these things. What if it's, we talked about if it's in factored form. I can go from this form to standard form by multiplying everything out. But what if it's in standard form? How do I write it in factored form? So first we got to think about factoring. So you need to know what a prime number is. And just some review stuff. What is a prime number? A number that is divisible by 1 and itself. Those are the only two numbers that can divide into it. And that number has to be bigger than 1. So 1 doesn't count as a prime number. So we're going to start with 2. 2 is divisible by 1 and 2 only. 3 is divisible by 1 and 2 only. 4 is divisible by 1, 2, and 4. So 4 is not in there. 5 is divisible by 1 and 5 only. 6 is divisible by 2 and 3. 7 is divisible by 1 and itself only. 1 and 7 are the only factors. 8 I can divide by 2, 4. 9 I can divide by 3. 10 I can divide by 2 and 5. So none of those are prime. 11. I'm not going to go through every number. 13. Pause the video and see if you can get the first 10 primes. Right now we've got 6 of them. Okay, welcome back. So then the other ones you should have had are 17, 19, 23, and 29. Those are the first 10 prime numbers. What is a factor? A factor is anything that is multiplied. Remember, the product is when you multiply a bunch of stuff together. Each one of those things, each part of the product is called a factor. Put it all together, what is prime factorization? That means factoring a number down to its primes. So we've done things like 100. I could factor that into 50 times 2. I can factor the 50 into 25 times 2. I can factor the 25 into 5 times 5. And now it's down to its primes. So prime factorization of 100 is 5 times 5 times 2 times 2. All right, so example 1, find the prime factorization of 36. So you're going to pause the video here and you're going to do that on your own. All right, welcome back. So the prime factorization of 36 is 2 times 2 times 3 times 3. I'll pause the video again and try to do the prime factorization now of 504. Okay, welcome back. Well, I've got 2 times 2 times 2 times 3 times 3 times 7. So hopefully you got the same thing, and then we're both correct. Knowing what a factor is and how you describe a common factor. A common factor would be things that are multiplied together, and the common part, maybe they're the same. So we're going to be looking at really the greatest common factor. What factors do they have in common? And they have to be the biggest one. So find the GCF of the following pairs of numbers. So 24 and 90. Okay, welcome back. So for this one, it is 6 is the greatest common factor. It's the factor, like I can break 24 into 6 times 4. I can break 90 into 6 times 15. So the factor they have in common is 6. So the answer is 6. You can try 108 and 80 on your own. Okay, welcome back. The answer is 36. Greatest monomial factor is a similar idea. The only difference is that the factor could contain variables, but it does not have to. So let's do some examples for looking at taking out the greatest common factor, seeing what's left over. So again, we're taking a quadratic, let's say, or a polynomial that's not in factored form. Remember, factored means multiplied. These are connected by addition. And I want to turn it into like things times each other, make it into factored form. So the greatest common factor is, what do they have in common out of these two terms? So this has two terms. Terms are separated by the addition. So that's the first term. Actually, I'll write it like this. That's the first term. That's the second term. So the greatest common factor is 5, because first I do the 5 from the first term and the 10. 5 is what divides out of both of those. Now I look at the next part of each term, the x's. The biggest thing that I could divide out is x. So my greatest common factor there is 5x. Factored form means I'm going to write the greatest common factor as my first factor times something. So now we're doing division here. We're going to take this original guy and we're going to divide it by the greatest common factor, and that's how we can write factored form. We know that this thing is going to be equal to 5x times something else, and that's what we're trying to write over here. It goes back to when you first learned division. You might have seen problems like this. 15 times what number equals 30. And you would figure out what number goes in the box. And so we could say that 30 can be written as 15 times 2. So it's the same idea here. I'm taking this whole polynomial and I want to write it as two things times each other. And when I figure out the greatest common factor, I'm getting the first part, like the 15 here. And I know what I want it to equal. I know I want it to equal this whole polynomial. So how do I find the missing factor? You do division. You divide by 15. And that's how I can come up with the 2 here. Because 30 divided by 15. I take the whole amount and I divide by the common factor, or whatever the factor is I know. So that's how I'm going to figure this out. I'm going to take my original, I'm going to divide it by the common factor. Now, I can only divide each part one at a time. So if I do this division here, I end up getting x. So that's how I get the first part. When I do this division, I get 2. So now I've factored this as 5x times x plus 2. So now I can use the zero product property. I can rewrite this side of the equation as 5x times x plus 2 equals 0. I took something that was not factored and turned it into factored, because now it's 5x times that thing. So now I know that if 5x equals 0 or x plus 2 equals 0, by the zero product property I get x equals 0 and x equals negative 2. So then x would equal 0 and x would equal negative 2. So notice what I did here. I did not write the parentheses on this first term anymore. I only need parentheses when I'm multiplying by something and it's got addition or subtraction in it. If it doesn't, I just leave, I don't need the parentheses on the 5x. So that's why we're doing this. We're taking something that's not in factored form into factored form. Now this guy's got 3 terms. I'm going to show you, I'm not going to go through all these steps on the right. I think sometimes it could make it more complicated to write it in factored form. I'm going to show you how I think of it. So we've got 3 terms here. I have to decide what's my greatest common factor. And I'm going to write that down. So first I look at just the numbers, 4, negative 6, and 14. Well, I look at the smallest one, 4, and I think of the numbers that go into it, 1, 2, and 4. 4 is the biggest one. So those are the only factors that could be common, 1, 2, and 4, because those are the only factors 4 has. For it to be common, it's got to be in every term. So I start with the biggest one, 4. Does 4 divide into all the other ones? No. I take the next biggest one, which is 2. Does 2 divide into all 3 of those numbers? It does. So my greatest common factor is going to start with a 2. Now I look at the x's. I got an x to the 5th, an x to the 3rd, and an x. My greatest common factor will be x, because the most I can take out is 1x. I can't divide out 5 x's. I could divide 5 x's out of the first term, but I can't divide 5 x's out of the third, out of x to the 3rd. It doesn't have 5 for me to divide out, and I certainly can't divide 5 out of there. So remember, it's the greatest common factor, and the key there is common. It's greatest, but it's also common. So you got to kind of pick the biggest one out of the smallest number. Like, so when you have x to the 5th, x to the 3rd, x to the 1st, I'm going to divide out an x to the 1st, because I can take, that's the most I can take out of each term. Because of that smallest one, that x to the 1st, I can only take 1 out of it. So once I decide my common factor, if it doesn't have any addition in it, it doesn't need parentheses. So I just put parentheses around it, but it doesn't need them. Times, now the next thing will need parentheses. This will have, a little tip here, this will have however many terms my original has. So this should have 3 terms in it. So I divide the common factor out of each one at a time. I'm going to buy myself some room here. So I'm going to take the first term. I'll do this in another color here. 4x to the 5th, and I'm going to divide out the common factor, 2x. What's the result of that? 2x to the 4th. And you can always check your work. I like to do this. If I multiply the common factor back out, I would get this answer, right? 2 times 2 is 4. x times x to the fourth is x to the fifth. You can always check your work as you go. I like to do that. Now I'm going to do the next one is negative, the next term, I'll just put a little semicolon there. Negative 6x cubed divided by the common factor 2x. That will give me my next term. Well, it's going to be a negative because a negative 6 divided by 2 is a negative 3. Then x to the third divided by x is x squared. Again, if I multiply the common factor, if I distribute it, I should get back to that answer. 2 times negative 3 is negative 6. X times x squared is x cubed. Lastly, I've got 14x, and I'm going to divide out the common factor 2x. That will lead to 7, a positive 7, and no x in it, because the x's divide out to be 1. So there we go. I have factored this thing. I know there's a lot of addition and subtraction in there, but it's because of this multiplication right there that now I have a product. I've got a first factor times a second factor. Some people may say there's 3 factors here, because you could say this means 2 times x. So you could say a first factor, a second factor, and then a third factor. It depends how you want to look at it. And that's all they want us to do. They want us to write it in factored form, which I did right here. Okay, I've got some stuff going here. I'm going to clean it up so we can focus on the answer. So this is the answer in factored form. I also don't want those dots in there. All right, let's try to, they want us to do the same thing here. What's the greatest common factor? Well, first of all, I like to determine how many terms I have. I have 2 terms. 8 and 12, the biggest number I can pull out is 4. A squared and A, the most a's I can pull out is always the lowest number. B's, the most b's I can divide out is always the lowest number, that b to the first. C's, they both have c squared, so I can divide that out. Remember, that's my greatest common factor. So now I know it's that times something else will get me back to my original. Again, think of that when you learned division. 2 times what would equal 10? We have that going on here. We now know it's this times blank equals the original. So how do we find out what goes in the blank? We can divide the original by the factor we know. So that's what we're going to do. We're going to divide this original by the factor we know, the greatest common factor. So that's how we're doing factoring here. So I'm going to divide a squared b c squared by 4ab c squared. That's the common factor. 8 divided by 4 is 2. A squared divided by a is a. B divided by b is 1. They actually cancel out and there's no b's left. And then c squared divided by c squared is also 1. They cancel out. Now I'm going to divide the next term by the common factor, ab c squared. Let me buy myself some room again. I don't give myself enough room to do the division. So this was divided by 4abc squared. Now we're going to divide that term by 4abc squared. So negative 12 divided by 4 is negative 3. The a divided by the a is 1, so the a's disappear. B squared divided by b is b. And then c squared divided by c squared is 1, so the c's disappear. So this is factored form. Okay? You can pause the video and try to do number 4 on your own now. Okay, welcome back. This is what you should have gotten. A negative 3 was our common factor, and then I get the rest there. So again, this is a product because of the multiplication that occurs right here between negative 3 and the other factor. All right, how about number 5? Pause the video, see if you can do it on your own.